Good afternoon, everybody. I want to go ahead and try to finish up this presentation while we're at home again with the cold weather. So if you want to go ahead and finish your notes in your notebook, if you don't have your notebook with you at home, you can always put it on another piece of paper and then add it into your notebook and attach it in later on when we return to school, whenever that will be. So we're talking about aircraft size. We look at left here with this pilot sitting in the engine to show you how tall or how big the actual engine is. Then, of course, back when we had a space shuttle fleet, this is how they would transport them from location to location. They put on basically the top of an airplane and then fly it across the country. But, of course, that's no longer needed because we don't have any more space shuttles. Instrument panel. This is a very primitive, or not primitive, but a very basic instrument panel. From an older aircraft, which we'll see instrument panels later on more when we get into flight sim. Of course, more modern instrument panels, you can see the radial stack right there on the right side, and another instrument panel here also, just a zoomed in closer picture. Center of gravity, we've already kind of discussed, but and if you had POE, you've seen this before also. But center of gravity is a point where weight of object is balanced. So of course in a triangle, you want to find that location. In a square or a circle, very simple, right? It's with multiple lines of symmetry located at the intersection of lines of symmetry. And that's important in stability. Aircraft with positive stability returns to steady flight after disturbance. So if they have positive stability, if there's a disturbance, like here in this picture, you see an updraft over the road as warm air rises, that would take the flight path up. But if the aircraft is stable, then it should by itself stabilize and return back to its flight path after the disturbance. Maneuverability is an indication of an aircraft's ability to handle the stress of maneuvers, and controllability is an indication of an aircraft's ability to react to pilot inputs. If I were you, I'd go ahead and then write down those last two about maneuverability and controllability in your notebook. And of course, you can pause this anytime you need to write stuff down and play again. Attitude, we'll talk more about this one when we return, but to kind of go over it with you right now. Aircraft have three axes of flight which intersect at the center of gravity. You have longitudinal, you have lateral axis, and then you have vertical axis. And of course, the important piece of the plane, or parts of the plane, we have center of gravity and then center of pressure. Aircraft must be stable around these three axes for controlled flight, and aircraft must be controlled to rotate around these three axes to change direction. Roll has to do with longitudinal axis, if you want to write that down. So the plane can roll left or roll right. Okay, think of it that way. Pitch has the lateral axis, you can write that down, and that has to do with pitch up and pitch down, whether the nose goes up or down. And then yaw, or vertical axis, go and write that down. That would either yaw right or yaw left. Longitudinal axis, to turn left, aircraft must roll left. Okay, so we're talking about roll left, roll right. The right wing must raise and the left wing must descend. So this goes back to creating lift, or creating more lift, or creating more drag. So if you notice in the picture, it's kind of hard to see, but they show the aileron out here on the left wing. That aileron is actually going up. That's creating more drag, making that left wing dip. The right aileron is actually going down, which creates more lift and making the right wing go up. And they show it in the picture here. Here's the right wing, aileron down. You increase the angle of attack and get more deflection, and then therefore you have increased lift. On the left wing, aileron up, this guy out here, the yellow, and you see a decreased angle of attack. It creates more drag, and therefore we have decreased lift, and that left wing dips, and that gives us a roll left. Flight controls that cause the ailerons and flaps to move. Well, for this one, we're looking at the yoke here in the picture, and so the pilot would roll or turn the yoke to the left, and that makes the aileron on the left wing go up, and at the same time the aileron on the right wing go down. And I haven't been over flaps yet, but we can talk about that a little bit later on. I also have the model RC plane ready to go. I can show that to y'all when we return to the class also. And flaps, well, we can go and mention it, are only used mainly during takeoff and landing. It helps generate more lift at slower speeds. Obviously you want lots of lift during takeoff so you don't crash at the end of the runway. So the pilot will lower the flaps down to create more lift, and then of course when they get up in the air, they'll retract the flaps to decrease drag, because flaps do increase the drag while they increase lift. When they land, obviously they don't want to land too fast, but they want lots of lift. So once again, they'll extend the flaps, and that will increase lift, and they can land at a slower speed. That way they won't crash in the ground or don't risk going too fast as they touch down on the runway. And there's a control they actually use the flaps. That controls both flaps at the same time, the left and right wing, and that is the inner part of the wing close to the fuselage. So that is the 30 degrees you see on the picture. There's 0, 10, 20, and 30. So right now in the picture, the flaps are lowered at 30 degrees, and that's all the way down. Typically when you're flying, you'd have them up at 0 degrees, but you can have different settings there, depending on how much lift you're trying to create. Pitch, that's lateral access. This time to descend, the pilot reduces power and lowers the elevator to pitch down. So elevator, remember, is the yellow part back here. That's part of the horizontal stabilizer. So what happens is you lower the elevator. So once again, by lowering it, that increases the angle of attack, therefore gives more lift, and that makes the tail go up, but it makes the nose go down. So that's how you pitch down, by putting the nose down and making the tail go up. And that is done by the pilot pushing the yoke forward on the controls, and that is what makes the elevator do that. And then there's elevator on the small plane. Of course, we have a bigger plane. I'll show that to you when we return. For y'all, now we're looking at the rudder, and this is also the vertical stabilizer here, and the yellow part's the rudder. So this, they're going to use the foot pedals by the pilot's controls. And if they want to yaw left, then we see here the rudder goes to the left. Once again, it increases the angle of attack here, and then increases lift to the right. Therefore, it makes the aircraft itself yaw left, or the nose go left. And that can be used in the air and also on the ground. And our RC plane also has a front wheel that turns, and so you'll see that when I use the rudder controls in class. But to yaw the aircraft nose left, the rudder must deflect left. And so there, the pilot would push the left pedal away from themselves. So they push down the left pedal. And that's how you yaw left. And there's the rudder on that aircraft, and I'll show you it on ours when we return. So here, looking again at these three axes, you have longitudinal, lateral, and vertical. Longitudinal, the motion is roll, stabilized by the wings. Aircraft controls the aileron, that's the outside part of the wing. And once again, over here in the yellows, right there, left and right. And then the yoke twist left to right is the pilot input. For lateral, motion is the pitch, stabilized by horizontal stabilizer. The aircraft controls the elevator, and the pilot input is the yoke forward or aft. And then vertical, motion is yaw. That's the bottom picture down here. And then the stabilized by the vertical stabilizer, aircraft controls the rudder, and then the rudder pedals, what the pilot uses as input there. And that's it for those notes. I'll put another video up later today about ailerons, or I'm sorry, airfoils. So right now you can cross this page out. It's on the line. It's on the bottom of the page, witness sign date also. If you don't have a witness, you can get a witness at school. But yeah, that's it. And if you have any questions, you can either send me. I wanted to add one last part here. I know we're done with the presentation, but when we left on class yesterday, I handed out 122. I like to work on that at home. If you have any questions, you can send me a remind text or email me. And then I also wanted to pass out to you yesterday 121, but I realized I have it on my table after you left yesterday. So if you have a printer at home, this is all in Power School Learning. You can print this off, work on it at home. Or if you don't have a printer, then you can write the answers down in your notebook, and then of course record or transcribe your answers back into on the worksheet when we return to class, whenever that might be. So please work on 122 for sure. 121 if you have a printer, or if not, write the answers in your notebook or record them somewhere, and then I'll get you a packet when we return to school for 121. I'll post the other airfoil video in a minute. That'll be 123. But there is not we'll do the activity when we return to school. I'll just post a video for the notes on that also. And that one I believe I have up here. Yep, ready to go. So I'll post that video. Thank you very much, and we'll talk later.